Is this the weak point of Starship? Alternative ways to protect the Starship. Are heat tiles the way to go? Starfactory receives the long-awaited Windows, the construction of Massey's static fire stand continues, Voyager rescued, and Rocket Lab launches a solar sail mission. My name is Felix, welcome to What About It, let's dive right in. Starship updates. Welcome back to Starbase. Today's episode is all about heat tiles. Want to know why SpaceX isn't using more glue or how originally Starship was supposed to sweat? Welcome to the ultimate Starship heat shield guide. Let's take a look together. In less than a month, we could witness the largest rocket in history soaring again through the skies. IFT-4 is drawing closer and we even have a launch date update. But before that monumental event, there is still plenty to sort out. Over at the high bay, the saga with the heat tiles continues. Each day pictures show rapid progress with more tiles being reattached. Despite the speedy work, many of them still need replacing, so it is unlikely that this prototype will exit the bay this week. Additionally, zooming in on the tiles reveals something potentially concerning. Many tiles have lines drawn on them which might suggest cracks. Confusingly, they also have an OK written in a circle at the top, so it is unclear whether they also have to be replaced. We've seen these confusing signs many times now. This is the perfect moment to address some frequently asked questions about the heat tiles that pop up whenever we discuss them. They range from the standard tile, which is attached via metal pins and way thinner than the others for weight reduction, to thick ones from the leading wing edges, which are attached with glue. Contrary to common belief, even the hexagonal tiles are not all standardized. On the nose cone, for example, you'll find hexagonal ones that are much thicker. They are identical from the black side, but not from the rear. You might have noticed that some tiles have a white layer underneath. This is a type of white ceramic mat that acts as additional insulation for the ship's front during re-entry. While the tiles themselves are the primary insulators, this mat helps to minimize heat transfer. You want the tiles to get hot, but not the hull. It could also improve the prototype's chances of surviving re-entry, especially if parts of the tiles were to chip away. We've also seen questions asking why the glued tiles lack such a mat. The answer here is pretty straightforward. Nothing would be holding the tiles if the mat were glued directly onto the ship's surface. They need a direct bond to the ship's body to stay in place. Otherwise, they'd simply rip off during launch. On the other hand, we often receive questions about why they don't just use glue all over the entire prototype to prevent the tiles from falling off during events like static fires. While it sounds like a feasible solution, several factors must be considered. Firstly, applying glue to the entire surface of the ship would be time-consuming. Currently, the clips that hold the tiles are added using welding robots, allowing workers to click each tile into place within seconds. In contrast, applying adhesive evenly across the entire ship would require precision and could significantly slow down the process. Another issue is serviceability. They like to crack. Replacing a damaged one would be a pain if each tile were glued directly to the ship. With the current clip system, a broken tile can be removed and replaced within minutes, whereas removing adhesive and preparing the surface would take hours. However, perhaps the most crucial reason for using clips is the thermal expansion of the heat shield. The tiles are designed to expand slightly when heated during re-entry, sealing gaps between them. Without the clips providing the necessary play, there would be almost no margin for error. Tiles glued too closely to each other would just crack during re-entry. Another vital question is why use tiles at all? Can't they construct Starship from a different material or use other, more reliable technology? Well, that depends. Initially, what we now know as Starship was called the BFR, or Big Falcon rocket. Back then, it was intended to be constructed from carbon fiber rather than stainless steel. And it wasn't just an idea thrown out during the initial design phase. SpaceX actually manufactured several BFR components using carbon fiber and even conducted cryogenic testing with a carbon fiber tank. That was a long time ago. However, the engineering team quickly encountered significant issues with this material. While carbon fiber offers the advantage of being lighter than steel, it is considerably more costly. This would make producing hundreds of prototypes incredibly expensive. Moreover, fabricating tanks from carbon fiber is a complex process requiring specialized winding machines and large industrial ovens. Not the best setup for a hardware-rich program. However, the most substantial issue was this material's operational temperature range. It would have required additional insulation to survive re-entry, making it even more complex. Ultimately, stainless steel was chosen for several reasons. As said, it is much less expensive than carbon fiber. Secondly, once engineers developed an effective welding technique, it proved far simpler to produce prototypes at scale while also being able to modify the design on the fly. Though there are other things you can use to eliminate the heat shield entirely. Materials like tungsten, Inconel, or certain carbon-carbon composites offer insane temperature resistance, but their use is limited either by high-cost manufacturing challenges or both. So, are we destined to rely on heat tiles for the entirety of the Starship program? Not necessarily. While the material Starship is made from is likely to remain the same, a variety of heat shields could be considered for use. One example is an ablative shield, a tried and true method used on numerous vehicles including the Apollo capsules and Dragon 2. This type of heat shield offers several advantages. It's less brittle, can be applied in large segments, and is less sensitive to peak heating. You might wonder, if ablative shields are so good, why doesn't SpaceX use them on Starship? The term ablative is the key here. It means that the material gradually erodes during re-entry as it dissipates heat. In a worst-case scenario, Starship's entire heat shield would need replacing after each flight, or at best it would survive a handful of launches. But the point of Starship is to be rapidly reusable. Replacing such a big part after just a few launches is unacceptable. Another option is regenerative cooling, a technique commonly used in rocket engines including the SpaceX Raptor. Some engine belts feature small channels that allow fuel to flow through, keeping the engine from melting itself without needing ablative materials. This concept could be scaled up and applied to Starship, featuring an external shield with underlying channels to cool the spacecraft during re-entry. This isn't a purely theoretical solution either. For example, the second stage of Stoke Space's Nova rocket utilizes a variant of this method in its active heat shield. However, if this were the ultimate solution, SpaceX would likely have adopted it already. So why haven't they? There are two main drawbacks. First, such a system would significantly increase the mass of the rocket. The current heat tiles used on Starship are incredibly lightweight. It almost feels like holding styrofoam. Whereas an active cooling system would require additional steel, increasing the overall mass. Another challenge with implementing active cooling on a vehicle as large as Starship is the need for significantly more fuel to run the cooling system, which would again increase the spacecraft's mass. And Starship is all about getting rid of that mass. Finally, there's the issue of reliability. Although it might not seem so at first glance, once the heat tiles are perfected, they create a reasonably dependable system. Losing a few tiles in non-critical areas of Starship likely won't be a big deal. However, with an active cooling system, a failure in a component such as a turbopump, which circulates the cooling liquid, could be catastrophic. The active cooling would stop. Similarly, a blockage in just one cooling channel could have severe consequences. A passive heat shield is less likely to fail and far less complex. Another intriguing concept considered for Starship is transpirational cooling, which essentially allows the rocket to sweat. This method would replace heat tiles with a surface covered with hundreds of thousands of tiny holes, ejecting liquid methane during re-entry. The methane would then vaporize upon exposure to the intense heat, forming a protective barrier around the spacecraft. Transpirational cooling can not only work in some extreme conditions, it also doesn't care about the rocket's shape. It is the ultimate solution. Elon Musk has mentioned this method several times, but ultimately the idea was shelved. Maybe they discovered that the additional fuel consumption just isn't worth it, or the technology is way more complicated than initially thought. For the time being, Starship continues to rely on heat tiles. However, much like the Raptor engines have evolved and improved over time, we can expect the same to happen with the heat shield. What do you think? Are the tiles the way to go? Do you have any other Starship related questions you want to see answered? Please let me know in the comments. Before we go back to more Starship news, here's a quick word about other news. Did you know 3 companies are in the running for NASA's next moon rover? Through ground news, I found 56 articles about this topic. Whoa! What? Wow! Ground news combines all the world's news in one place so we can compare coverage. I've been working with ground news for over a year now, and I think what they are doing is really important, especially today where space news doesn't often dominate the headlines. Click the link or scan the code to discover news you have missed. Looking at this story, nearly all the articles are coming from the left and center, so people who get their news from the right might not know about this. Comparing the headlines, we can see some interesting distinctions, revealing left-labeled articles emphasized advancements, while right-labeled articles highlighted importance, as in NASA astronauts to drive moon buggy for first time in half a century. Through this, ground news illustrated how this topic is presented in varied ways to different audiences. And you can do this on any topic. I've been following news on SpaceX, aviation, NASA to get the latest news and make sure I'm getting diverse perspectives. Go to ground.news/y for 40% off the Advantage subscription, the same plan I use to research these topics, and by signing up you will be supporting our channel. So that segment about the ship was a pretty long one today, but what about the booster? There it is, still parked at the first megabay. Thanks to Redline Helicopter Tours, we've confirmed that it hasn't yet received its hot staging ring, but that should happen soon, especially as we're seeing the first signs of the launch being close. For example, during Flights 1 and 2, NASA used the WB-57 aircraft to monitor the liftoff, and as such, the scheduling of this plane hinted at the launch window. NASA's calendar has a placeholder for imagery support from May 16th to May 26th. While it is not set in stone, this suggests that the window for Starship's fourth launch could open around those dates. Sources tell us that the liftoff is scheduled for May 25th, but again, this isn't official, so don't book your flight to Starbase just yet. While we discuss the production site, let's also consider the future of Starship production automation, the Starfactory. Yes, your eyes are correct. The final phase of the factory now connects to the original building. Interestingly, the structure expands even further, so the final building will end up really close to the second megabay. And then there is not much room for Starship sections. We may still be able to see them when looking from the front. Our photographer John captured workers installing the first strip of the glass window on the factory's facade. The new ring yard might be behind these windows. This will change into an exciting sight for us. A ton of progress can also be seen at the back of the factory in the mezzanine section. Currently it has 3 levels with some of the flooring already in place. It's incredible how much you can discover by looking at things from the air. Did you know that you can take a helicopter ride over Starbase and get the same views as in our videos? Visit redlineheli.com/Felix to book your helicopter ride over Starbase with $25 off. Give it a try, you'll love it. We've also looked into our channel metrics. Over 2 million returning monthly viewers have not subscribed yet. Help us grow the channel even further by double checking that you've hit that subscribe button so you don't miss our updates. And while you're at it, give us a like and become a wise supporter for exclusive SpaceX updates. With it, you get access to daily Starbase photo galleries, including satellite, aerial, and ground photos of SpaceX's progress, and countless other extras on top. And no matter how much you decide to give, everyone gets the same supporter content and access. You decide what you want to give. And just as a reminder, on April 19th, we've launched one of our most ambitious projects yet, Y Live. We have cameras at Starbase and Port Canaveral. You may have seen snippets from these cameras before, but now you can watch them 24/7. And not just that, we've live streamed heli flights and show pictures, launches, tests, and interviews. It is packed. Thanks for watching. Okay, back to Starship news. Our final stop in Texas today is Massey's test site, and oh boy, progress has been made since our last flight. Despite the clouds trying to disrupt our plans, yet again our determined photographers captured some exciting images while also live streaming them to you. Most notably, we now have a clear view of the ship quick disconnect installed above the trench we discussed in the last episode. Beneath this structure is a solution to a mystery puzzling us for months. If you remember, we discussed what was called the Kit Kat frame months ago. At that time, the consensus was that it might be a part of the flame diverter. However, it turns out that that speculation was incorrect. It's a work platform. If you look closer at the diverter, you'll notice 2 rails where the platform rests. This setup will allow the platform to move, covering the opening so workers can access the engines before testing. At the back of the flame trench you can also see green pipes, which are part of the water supply system for the diverter itself. The flame bucket hasn't been installed yet, as you can see here, but the wall and support structures are all in place inside the trench. Workers have also added concrete to the front of the trench, allowing the SPM transporters to bring in the test stand and the prototype itself. With all these components now moved into place, we might soon see a continuation of testing at Massey's. Cameron County released new transportation closures, indicating upcoming testing activities. Interestingly, the closures were quite specific this time, noting that on April 25th a booster would be moved to this facility from the production site. Since that date has already passed, if the move went as planned, you'll see the pictures now, excitement guaranteed. While Starship represents a possible future of interplanetary human travel, NASA has long pursued dreams of exploring interstellar space. This ambitious vision led to the launch of two groundbreaking probes in the late 1970s, Voyager 1 and Voyager 2. In its early years, Voyager 1 conducted flybys of Jupiter, Saturn and several of their moons, gathering invaluable data. Interestingly, it also carries a 12-inch or 30-centimeter gold-plated copper disc loaded with information about Earth, humanity and our culture, as well as instructions on how to locate us.
And on this record are a sampling of pictures, sounds, greetings, and an hour and a half of exquisite music. The Earth's greatest hits.
While such a payload might seem pointless for a mission within our solar system, the Voyager probes were designed to venture into interstellar space from the beginning. Let's hope that whoever finds it has good intentions. Despite being the second to launch, Voyager 1 was the first to enter interstellar space in 2012, with Voyager 2 following shortly after in 2018. Currently, Voyager 1 holds the record of the most distant artificial object from Earth, located about 24 billion kilometers or 15 billion miles away. That's 162 times the distance from Earth to the Sun. Imagine the Sun being 162 times smaller than you see it here on Earth, a tiny little star. Over the years, however, the spacecraft has experienced its share of wear and tear, with several critical moments that could have ended this mission. One such incident occurred last November, when Voyager 1 began transmitting gibberish data, rendering it unable to conduct research. Despite months of troubleshooting, the problem persisted. That was until March of this year, when engineers found corrupted code in the onboard computer's memory responsible for data packaging and transmission. As a potential solution, they decided to relocate the damaged part of the code to the memory of other devices. Given the immense distance, the command took 22.5 hours to reach Voyager at light speed, with an equal time for a response. The outcome? Voyager 1 successfully transmitted a healthy status report, paving the way for the resumption of its scientific research. The people at Jet Propulsion Laboratory have to be magicians. The number of space hardware they were able to rescue over the years is just insane. If anyone from JPL is watching, you truly rock. Voyager 1 is back in the game. Lastly, staying on the interstellar travel, Rocket Lab just completed a launch that could pave the way for a mission to another star. You heard me right, that is just a bit more than 162 times the distance from Earth to the Sun. Instead, think millions of times. On April 23rd, an Electron rocket lifted off from New Zealand's LC-1B, this time carrying payloads from two different clients. The first was CAST with their prototype satellite NeonSat-1. It's a small Earth observation satellite designed to function within a constellation of 10 spacecraft. Excuse me, why am I talking about this mission? The second payload was from NASA, named the Advanced Composite Solar Sail System, or ACS-3 for short. This small CubeSat is equipped with a solar sail, a potentially game-changing technology for space propulsion. Unlike traditional spacecraft, this type of vehicle doesn't need fuel.
So does it run on pure magic or what?
No. Instead, it deploys a massive sail that catches the light particles emitted by the sun or a strong laser, which then pushes against it. The thrust generated is minimal, but over time it accumulates, potentially allowing the probe to reach speeds as high as a few % of the speed of light. This might not sound impressive at first, but in the context of interstellar travel it is monumental. For example, the mission Breakthrough Starshot, Stephen Hawking's last big idea, aims to reach Proxima Centauri, our nearest star, in just under 30 years, a significant reduction from the thousands of years it would take with conventional propulsion. Obviously, it is easier said than done. To reach such speeds, you would need a powerful Earth-based laser to propel the sail. Moreover, the probe must be incredibly lightweight. The entire setup, including camera, shielding, onboard computers, and the sail must weigh just a few grams. The solar sail launched on this Electron mission isn't quite at the cutting-edge technology level needed for Starshot, but it represents a critical step forward. Its primary task is to test new composite booms that are lighter and more robust than traditional metal ones. With the rapid advancement of technology and new manufacturing techniques, who knows? We might just witness the launch of an interstellar solar sail mission within our lifetimes. Wouldn't that be something? That's it for today. Remember to smash that like button, subscribe for more awesome content. This is what fuels the algorithm and helps us immensely. Check out our epic shirts in your favorite Space Nerd store. A link is in the description. And if you want to train your space IQ even further, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode. Cool B-roll, right? You're fine. Precision. I'm sorry.